Welcome to the talk. My name is Ivan, and the guys up to now have been talked about how to write your tests, how to organize your tests, what to use. I'll be talking a bit more about how to run your tests. I run a small company called Big Fish Software in Zagreb, currently a one-man band. I'm also involved in the community a lot. I'm one of the organizers of the WebCamp Zagreb conference, and along with Luka, I'm one of the organizers of the Zagreb PHP meetups. So feel free, to come find me about that if you want to, if you're interested. I did some work for the Apache Software Foundation. I have some experience in running open source projects, and that's what I'd like to focus on today. So this is your basic approach. You write some code. It has to be very intelligent. And you want to be sure that it runs and that it works as expected. So you write a test. And the test does some reasonable code coverage. It checks your vital potential problems. It confirms there are no obvious problems with your code. Of course, you might want to write the test first. Some people do it. I don't. But either way, you configure your testing framework. This is just the simplest possible way. And you run your tests. And the tests will confirm that you have no obvious problems with your code. And then feel free to push your code, deploy, whatever. Yeah. But is this approach good enough? For a lot of projects it is, because if you're running a small library which you just use for yourself internally, you don't need anything else. If you're alone working on a project, no problem. If you're self-disciplined enough and not lazy enough to actually make yourself run your tests every time, great. So you don't need anything else. But a lot of us are not that, and we work on projects which have many people working on them. You have to integrate your code. You have to be careful that you don't accidentally deploy something which is broken, which I have done on several occasions. So this is where continuous integration comes into play. Martin Fowler here he's a really clever guy and has a good definition of it. But basically what continuous integration means is that you merge your code to a central branch somewhere where all the developers who work on a project merge their changes continuously. Merging just basically means you want to push to a central branch, and continuously means you do it often. You do it daily, you do it more often than daily. This way you will actually find any problems you have with merging your code soon. You will find it quickly, and you will have plenty of time to fix those problems before they become a serious issue. So earlier detection, earlier fixed, everybody's happy, So this is in contrast what usually big projects used to do is they create a feature branch and then they work on this feature branch for months and then they decide to integrate it into the trunk or whatever you call it, master. And this takes another 3 months, or maybe this fails and it's horrible and conflicts and so basically if you do it often, you won't have the problem, you will just be easy. So. In our world, especially in open source world, the central branch is usually provided by GitHub. There are other services, Bitbucket and so on, which are just as good, but this has become a sort of a standard. And one of my favorite things for running tests is Travis. So Travis is a hosted continuous integration platform. Basically, everything is run on their servers. There is no installation whatsoever on your part. It integrates with GitHub, at the moment exclusively with GitHub, but it has really good interactions because of it. On Travis, you can test all sorts of languages. It's a polyglot, and you can, even if it's not listed on this list, you can probably roll your own support for testing any language or runtime, let's call it. It also comes with loads of pre-installed services, so if your application depends on any of them, you can just use them on the virtual machine itself. You don't have to install them separately. To set up is 4 steps. It's easy. It's done in 3 minutes. And that's if you don't know what you're doing. So you basically go to Travis. You click login. It will ask you to use your GitHub account to log in and give it some permissions it needs. Once you're logged in, you get a list of all your repositories on GitHub. You just flip the on switch next to the repository you want to test. Presumed here is that you already have your PHP unit test set up. What this will do is Travis will use the permissions you granted it earlier, and it will go to GitHub and it will set up a webhook, which is just basically something which will contact Travis each time you push to GitHub. It will. Third thing you need a configuration file. This is the minimal configuration you need. Just need to tell, the language of my project is PHP. And some defaults will be inferred from this, we'll see later. But this means that Travis will know how to run your tests, basically. You push your code, you go to the Travis page, and you can see that it actually did the exact same thing you did locally in a minute before. It will run PHP unit, and it will tell you if your tests have passed or if they have failed. If they have failed, it will send you an email telling you, tests have failed, you need to do something. Go there, fix it. Okay? So this is a early error detection. So as soon as you push your code, tests will run. If they fail, you will get notified. You will know what to do, that you have to do something to fix them. Of course, Travis also does other things, but it has a list of all the builds you have done ever. So it will remember every time you break your tests. So this is additional motivation not to do so. So let's talk a little bit about configuration, because everything about Travis actually revolves around this configuration file that Travis uses. It's called travis.yml. It's in YAML format. It's really easy to write and to use. This is your minimal configuration. Language PHP. And Travis infers some things from this. So first thing it infers is that you have to pick a PHP version to use. You don't have to specify this. By default, Travis will pick PHP 5.5, and it will run your tests on 5.5. But you can also, this of course changes over time. I suppose they will switch to 5.6 in a couple of months or so. But it also means you can override this parameter. And one of the cool things, the first really cool thing you can do, you can specify multiple versions. So you don't want to run just test on 5.5 because yes, I use it in my development environment, but maybe if you're running an open source project, you usually want to support a wide variety of PHP versions. So here you can see that it actually, apart from the obvious ones, 5.4, 5.5, 5.6, and so on, it supports hip-hop virtual machine testing as well, which is really useful. So you can test your hack projects if you have any. So if you go to the Travis site after building with a configuration like this, you will see something like this. You will see that actually your build consists of 4 jobs. And if any of them fail, you will get notified. So typically what happens to me is I use some wonderful new thing from PHP 5.5 or 5.6, and I forget that it's not really supported in 5.3 or 4 versions which we try to support. And then one of these builds will break and I will know, I still have to use long array syntax, I hate the world, and so on. Okay, the other thing that is inferred from your language PHP setting is how to run your tests. And this is the script option, is basically tells Travis, how should I execute your tests? And I'm using PHP unit because this is, among other things, this is default setting. It is the de facto standard, but you can also override this option. For example, simplest override, you can give it some parameters to pass to PHP unit. This does some coverage report, which you can use later. But you don't need to use PHP unit. Luca was talking about conception a little bit earlier. So you can basically, this is just a shell command. You can take one or more, or a list of shell commands to execute, to run your test. And if this command returns 0, then it presumes the tests are successful. And if it returns something else, then they have failed. This is just standard shell scripting. You can also just roll your own and have some shell script which does whatever you want. So it's quite flexible. Or just leave it out and it will run PHP unit without any arguments, and you have all your configuration for tests in the XML file. There is actually a bunch of these scripts which you can set, which are run in order, which are listed here. So you have before install, which sort of sets up your environment before installing dependencies, install, which installs your dependencies, before script, which sets up your build in a sort of way that, so it just does things which are necessary for your test to run, things like set up the database or any other service you depend on. And then you have 3 hooks afterwards, which after success or failure, which run if your build is successful or not, and after, which always runs. And these are all similar to script in a way that they take one or more shell commands and they execute them. These are just provided as a convenience. You could theoretically put all your commands in just script and run them there, but it's nicer to have them divided into logical set of commands. So as a couple of examples, install is usually 90% of the time used to install your dependencies via Composer. So you just have a Composer install in your install option. This will run before you build, before the script. It will install your dependencies. You can also use it to do things like install some missing extensions from Petzl, or even you can use apt-get because this is they use a Ubuntu-based VirtualBox, and you can install a server you need. Let's say I had a project which required Solar server to test because I wanted to do the test all the way to the server and end-to-end. So you install it there. You can start it from there, stuff like that. You know. Before script, as I said, is used to usually set up your database or other services you need. In this example, we are using Postgres. Just create a database, load some data in there, so now I can run tests on my database. So the other really cool feature I like about it is the use of environment variables, the env setting. The env setting basically lets you define multiple values for one or more environment variables. In this case, I use the DB variable, which I give it 3 different values, Postgres, MySQL, and SQLite. And based on this DB variable, actually in the script, I use it to load different bootstrap files. These different bootstrap files will configure my test to run on one of these 3 databases. They're all present already on Travis's virtual machines, so you don't have to do anything apart from this. They're already running. So this is, of course, example. There was a project which actually generated some SQL queries which had to run on multiple databases. So if I wanted to test this actually worked, I wanted to do it all the way to the database, and this is a cool way to do it. And Travis will run your test once for each version for each entry in the env option. And now, to move on from there, I still want to test on multiple PHP versions. And if I set both PHP as various values and env, I will actually get a matrix of builds. It will test every combination of these 2. So this configuration actually runs your test 12 times, so to just cover all your bases. You know? I think it's really cool for open source when you want to support a lot of databases, a lot of PHP versions, and but it can sort of spiral out of control. There's also a new thing which they started now to testing on various OSs. So you can test either on Linux, which is default, or Mac. But that would mean, 24 builds. That's a bit pushing it, Open source projects they have a fair use policy, so it's not nice to hog all their virtual machines. Okay, some about the build matrix. You can tweak it. For example, a hip-hop virtual machine at the moment does not simply support Postgres driver, so I can tell it to skip that test. You can say matrix exclude hip-hop virtual machine on Postgres. So I will run only 11 tests. Also, you can tell it that some tests are allowed to fail, like I officially support PHP versions, but I don't officially support HHVM. So let's say any tests on HHVM are allowed to fail. I just want to know if they pass, but don't break my build if they don't. And another really cool option here is if you use the fast finish true, it will actually end your build before all the tests are run. So even if the tests which are allowed to fail are still running, it will finish your build, so you will know earlier that, if you have any problems. Okay, notifications. So that's what you really want to know when your tests are passing and when they are not. By default, Travis will send you an email. It will tell you your tests, if each time your tests break, it will send you an email that your tests have failed. Each time you fix them, it will send you just one email, they are fixed, and after that, as long as they're succeeding, you will not get any notifications because you don't really need them. This can be tweaked through options, of course. You can tell it to send notifications to some different email addresses. You can also use other channels of communications. I'm a fan of IRC. So you can tell it to, just notify me, I'll be on this channel, send me a message there. And it will actually, Travis bot will log into the IRC channel. It will tell you, the build has passed or it has not passed. Yeah, I like IRC, but usually when I talk about it, people have this reaction. But I think IRC is really good for development these days. There is a lot of developers. There's a lot of developers on there. The free node servers are really growing each year still. It's amazing. So try it out if you have time. But of course, also if you use any of the other group chats, such as Slack, HIP chats, whatever, there's a lot of them are supported out of the box. And if not, you can always use the after success or after failure scripts to, roll your own notifications. All right, there's also webhooks. Webhook is basically just on your own server, you create an endpoint which will receive post requests. And each time a build is run, Travis will post some data on there. So which commit, which version it was tested on, what has passed, what has failed, and then you can do whatever you like with it. Either your own notifications or statistics or whatever it is, whatever you need. So it's very flexible. Okay, so as an open source project, what you really want to do is you want to accept contributions. This is sort of the main premise of open source, and this combination of GitHub and Travis makes this a little bit easier. I won't say easy, but a little bit easier. So what I used to do when accepting contributions, I would get a pull request, I would check out the person's repository, his branch. Then first thing I would do, I would run unit tests. Let's see if he's broken something, And if he has, then I would just, fix test, submit again, reply. This is automated now, so if you go to your GitHub page and you go to the pull request, you will see that while the tests are running, you will get a notification which says tests are running, wait for it, If they fail, it will tell you tests have failed, the build failed, so you immediately know something's wrong. And if it succeeds, it says everything is good, feel free to merge. And then of course you will still need to do a code review because it's not safe to merge someone's code without seeing what they've actually done. Maybe they just deleted all the tests, you never know. So this is really nice. So Travis basically, apart from testing anything you push on there, by the way, it tests all branches and all tags. So anything you push onto, any branch you push onto GitHub, it will get tested, and all tags created will be tested, and all pull requests as well. So this is cool. And you get, as an open source project, you get all this for free. So it's a pretty sweet deal. So as the project grows, you often have, you start getting lots of tests. As Luca said, especially if you start moving to functional tests and acceptance tests and so on, things will get slower. So you really want to, there are a couple of things you can do to speed things up. First example is what everybody says, commit your composer log file. Okay, composer log file contains the actual versions you used when you tested it on your machine, when you installed it. And if you don't have a composer log file, when you do a composer install command, it will have to look through all the repositories and see what's the latest version that fits your criteria, and then install it. And so if you have a composer log, I have some Symfony components I want to use, there's 5 of them, and you just time how long it takes to run composer install. So without a composer log file, this will typically last something, this command, I've tried it a couple of times, I actually tried it on Travis as well, it will run something in the region of 20 seconds. If you have your composer log file committed, it will take 2 seconds. So that's an order of magnitude difference. And big projects can have really a lot of dependencies. You don't want to wait endlessly for your test to run. So this is a really good thing. Another thing Travis provides, unfortunately, this is for the moment not available to free repositories, only to paying members, but is caching. So basically what it can do, it can take your vendor directory for Composer, so dependencies you have installed, and when the build is finished, it will copy the whole vendor directory to S3, I believe, Amazon S3 to storage. And next time you want to run your build, it will first copy the vendor directory back to your project and then run a Composer install. What this really means is that the Composer install will not have to download all the dependencies, all the only things that have changed. So this will further, speed up the whole thing. So unfortunately, this is beta, not still available, but hopefully soon. Second thing you can do, which I really like, is you can parallelize your build. You can basically split up your tests into groups. I've just did some groups here called models, controllers, and views, but you just split something into sort of chunks that last approximately the same time. And you use the group option for PHP unit to run just one group. So like I said, this, when using env, Travis will run your build 3 times. It will run it once for each value of your environment variable test group in this scenario. So we'll get 3 builds, and each build will just test part of your code. This is cool because then these 3 builds can run in parallel, because this is all done on virtual boxes. It's not done on a single machine, and you can get much faster completion of your unit tests or any tests. Than if you did it all at once. So this is maybe not really necessary for most people, but it may be helpful for really big projects or slow tests. So Travis also has a lot of other ways to interact with it. So I usually use the web interface, but if you want something automated, you can use the API. It has a bunch of endpoints. You can do basically anything you can through the web interface and some extra things. I won't go into much detail here, but it's just things like, you get, typically you can get info about a repository, you can get a list of builds, and if they were successful or not, and so you can get detailed information about a certain build, so on. I haven't used API extensively, but I can see how it could be useful. The thing that I really like to use is command line interface client. So a lot of us live in the shell, and we do everything from there. You don't want to really move from there if you don't need to. So Travis provides a command line interface client. It's written in Ruby, as is Travis. It's available through Ruby gems. So if you have Ruby and Ruby gems installed, you just do gem install Travis, and you'll have it available. And it's basically a wrapper around the API. So you have loads of things which you can do here. Again, I won't list them all. If you're interested, just go check it out. One I forgot to mention here is Travis Open. It will just open your latest Travis build in the browser, in your default browser. That's useful. You can also do stuff like you can log in, so you can do some things which you need authorization for. It supports GitHub login, even 2-factor authorizations, which is I find cool for a command line client. And again, you can do stuff like list builds and see how certain build turned out and so on. You can also do stuff like cancel builds, restart builds if you're authorized and so on. It's a nice thing to have. Finally, there's also a third-party PHP library which works but hasn't really been much updated recently. I haven't had much use for it, but if you need it, it's there. It's tested on Travis as well. So this is just a topic I'd like to touch upon because there will be a more comprehensive talk later on. Continuous deployment. This is just basically the idea that if your tests pass and you're happy with that means you're happy with your code and you want it deployed automatically, so you don't have to do it manually. Travis out of the box supports a bunch of providers which he can deploy to. Some of the things I briefly tried was like Heroku, or if you're using Ruby, there's more stuff like Ruby gems and so on, PyPy for Python packages, Google Cloud Storage, I don't know. So for example, this is a very simple idea how it works. So there is a deploy option, and you needed to give it a couple of details. So first is the provider. That's one from the list you just saw on the previous slide. You tell it, let's say the provider is Heroku. Heroku has some of its own options. You need to tell it what your application is called. Let's say you have a staging application here, and you have to give it an API key to access Heroku. Of course, since we're talking about open source projects, you have to remember that that your Travis YAML file is public. Encrypt your key so you can put it in there, have it in available but encrypted. And you have to give it a condition. When should I deploy? In my case, I'm trying to deploy on my staging server here. So I want to deploy every time my develop branch passes. So we use the Git flow model, so we have a develop branch and a master branch, and develop is unstable, master is stable. So each time my develop branch tests pass on 5.6, which is the version we use in production, you should deploy my application to Heroku. So as soon as the tests pass, you'll have your application available on a staging server to try it out, do what you want with it. Yeah? Or finally, if your provider is not listed on the supported list you saw just a little bit, you can just use the after success hook to do something similar. So this is a hook which will run after success, is a list of commands which will run after your build has been successful. You can just have your script which will be run after this, and within the script you can also test things like what PHP version was it run on, and what branch was tested. It's exposed via environment variables by Travis, so you can basically do the same thing you did in previous step, but manually. Okay, and for the end, I have just a couple of more tricks. I like skipping tests. If you sort of just worked on your documentation or README files or whatever, and you don't want to run tests, you can add CI skip to your commit message, and then Travis will just not bother running tests for that commit. Retrying. This is really cool if you have a sort of a dependency manager which tends to fail. At one point, Composer had problems and it failed every now and then. So you can use the Travis retry command in front of your Composer install. What this will do is basically it will try to run this command up to 3 times, and if it fails, it will just redo. It knows that it failed by just checking the return status as an all-shell script, so you can use it for your scripts as well if they return a proper return status, return code. Okay, it has badges, so if you want to brag about your test passing or not passing, you can just use this URL to your repository and get an image back, which will either be the green one or the red one, depending on if your last build has passed or failed. And you can include this. It's typically included in the README file on GitHub, which is displayed by default when you open a repository, so people can use it from there. There are also other services which I really like, which provide additional badges. There is a coverall service which provides code coverage as well. So this is cool. You can have like thousands of badges, but just Google it. There's all sorts of things you can have with there. But this is what Travis provides. Okay. So I did most of my work on open source projects. I try to open source as much of my work, which I do for the commercial companies, if they will allow me. And but it's not always possible to have all your repositories public. And since Travis is so kind to give all this for free for open source projects, you still have an option how to test your closed source projects, and you can pay. Dish out a lot of money, and you can use Travis. And I must admit that Travis is not the cheapest candidate in this arena, since the cheapest plan is about $130. It does offer, it has no limits except number of concurrent jobs which you can run. So this cheapest plan is basically good enough for most people, unless you really want to leverage, you know, the parallelization and stuff like that we saw earlier. But there are other things which can use which are much cheaper. Especially, I'd like to mention the other day, Circle CI actually announced they have a free plan for closed source projects where you get one worker for free, which is really cool. I think this is the first service that provides this. So have a look at Circle CI. We've been using it at work. It's not as good as Travis, but it's quite good. You know, just to conclude, just use it. It's really that simple to set up. Once you set up, it will nag you each time your code fails, which is not something you look forward to, but which can be really useful. Especially if you have open source projects, there is really no excuse just not to set it up and let it run and you know. So, thanks a lot.